Question number 37 on the exam study guide. We are given an equation here. It's the equation for electrical resistance of two resistors in parallel. We are asked for the rate at which R is changing. So we want the derivative of R. Notice the derivative of X and the derivative of Y, the rates of X and Y are given. Notice they're both given per second. So we're given dx dt and dy dt. We are looking for dr dt. So we're given 1 over r equals 1 over x plus 1 over y. It's probably going to be easiest. I'm going to rewrite this instead of 1 over r. Let's write it as r to the negative first, x to the negative first, y to the negative first. That's going to be easier to make it. It's going to make it easier to take the derivative here. So when I take the derivative of r to the negative first, the negative 1 goes out front. I subtract 1 from the exponent times the derivative of r, so times dr dt. Same thing with the x, negative 1 out front, subtract 1 from the exponent times the x dt, and then I've got minus 1 y to the negative second times dy dt. We are looking for the rate at which r is changing. So we want to find dr dt. So we should be able to fill stuff in for everything else. So I've got negative 1, x to the negative second, so that'd be x squared on the bottom. I'm going to go ahead and rewrite it so that I've got x squared on the bottom. Same thing here, minus 1 over y squared dy dt. On this side, I've got negative 1 over r squared dr dt. X is changing at a rate of 1 ohm per second. So that is dx dt is 1. We're also told that x is 50. Y is 75. And dy dt is 1.5. We are not given r. It does not tell us what r is. It's whatever r is squared times dr dt, which is what we're looking for. So we need to find r. We know what x and y are, so if we go back to the original equation and plug in 50 and 75 for x and y, we should be able to solve for r. So 1 over r equals 1 over 50 plus 1 over 75. So I've got 1 over 50 plus 1 over 75. Let's change that to a fraction. So 1 over r equals 1 over 30. Pretty clearly r is 30. And from there, we should be able to solve for dr dt. So I've got negative 1 over 30 squared times dr dt is equal to whatever this side gives us, negative 1 over 50 squared times 1 minus 1 over 75 squared times 1.5. So negative 6.7-ish times 10 to the negative fourth. On this side, we want to multiply both sides by 30 squared over negative 1. And that should give us dr dt. Negatives cancel. So we should get a positive answer here. So times 30 squared, positive 0.6. Negative divided by negative should be positive. Positive 0.6 ohms per second. Resistance, notice in this problem is measured in ohms. Symbol for ohms looks like that.